Dear students, today let us study about Newton's second law of motion. So before studying Newton's second law of motion, let us recall Newton's first law of motion. So as you all know, the Newton's first law states that when the object is in motion, it continues to be in the motion, and when the object is at rest, it continues to be in the state of rest. So, here until the external force acts on that object, this object remains in its uniform motion. So, this is the statement of Newton's first law. So, the first law of motion indicates that when an unbalanced external force acts on an object, its velocity changes. That is, the object gets an acceleration. So we would now like to study how the acceleration of an object depends on force applied to it and how we measure that force. So before studying this, let us understand the term momentum. So what is momentum? It is the quantity of motion of a moving body where it is the product of mass and velocity. So momentum is given by mass into velocity, where momentum is represented by the letter small p, where it is equal to mass m into velocity v. So now let us suppose a ball which is having a mass 1 kg, which is when the force is applied on this ball, so it will have a velocity 10 meter per second. So it is moving with a velocity 10 meter per second. So what happens to its momentum? As we know that momentum P is equal to m into v. So if we substitute mass is equal to 1 kg and velocity is 10 meter per second, so we are going to get, which is equal to mass 1 kg into velocity 10 meter per second. So it is 10 kg meter per second. So here we get the momentum as 10 kg meter per second. So what is the magnitude here? 10. Yes, kg meter per second is the unit. So momentum is having both magnitude as well as direction. So momentum is a vector quantity. Okay, so here you can see kg meter per second. What is this? It is the unit. So what is the unit of momentum? Momentum SI unit is kg meter per second. So we know that momentum is mass into velocity. Therefore mass is measured in kg, velocity unit is meter per second. So momentum is kg meter per second. It can be written in this way. Okay. So whose momentum will be more if you consider? So if you consider a heavy object, whether heavy object or a light object is having more momentum, let us know. So as we know, momentum is the product of mass and velocity. We can change momentum by increasing the mass of an object. Suppose, let us consider two balls which are thrown with the same velocity of 10 meter per second. So let us consider one is of a tennis ball and the other is a cricket ball. Okay, here it is the cricket ball having more mass, and tennis ball which is smaller. So here which has higher momentum? Here the cricket ball will have higher momentum because it has higher mass. As momentum is directly proportional to mass, therefore cricket ball is having more mass, so here momentum of a cricket ball is higher due to its higher mass. So then whose momentum is higher, whether the object with higher speed or lower velocity? So as momentum is directly proportional to velocity, so momentum of an object moving at higher velocity will be higher. So if you consider ball, cricket ball, which is moving with a different velocity. So if a ball which is bowled by a fast bowler hits a batsman and hurts him, right? So but if a same ball is bowled by a slow bowler, it hits the batsman, it does not hurt. Why? It is because of higher momentum in case of fast ball. So in this case, mass of ball is same in both the case, but velocity of the ball is more in case it is bowled by the fast bowler. Okay, so momentum will also be more, right? And in the similar way, if the body is at rest, its velocity is 0 and hence its momentum is 0. But remember, every moving body possesses momentum, right? So when there is a velocity, then momentum is present. If the body is at rest, then the momentum will be 0. Understood? So now let us consider how the mass is depending on force. So dependence of force on mass. So for that, let us see the first scenario. Force required to push the object with same velocity. Now this you can see here, this two person, we want to move them with the same velocity. So we have to apply an external force. So here for this, the force required to push the heavier object, you can see here the mass is more, in the second case here the mass is less. So we require more force to move a heavy mass compared to in the second case less force is required to move a mass which is having less mass. So what is our conclusion here? So it is greater force is required to set the heavier bodies in motion compared to the lighter body. So here less force is required. So conclusion is greater force is required to set a heavier body in motion. That means force is depending on mass. If the mass is more, then the force required is more, right? So dependence of force on change in velocity. So how it depends, force depends on change in velocity. So if we consider the truck here which is having a mass 100 kg. So here this is moving with the constant velocity. So when it was moving with a constant velocity, different velocity, here this velocity of the first truck is more compared to the second truck. So the body which is having more velocity requires more force to stop it. In the same way, the body which is having less velocity requires less force to stop that body. That means greater force is required to stop bodies moving with higher velocity. If the velocity is more, the force required to stop that body is more. So here that means mass and velocity both are depending on momentum. So momentum is directly proportional to mass into velocity, right? That means now momentum is depending on force, right? So now let us recount some observation from our everyday life. During the game of table tennis, if the ball hits the player, so it does not hurt him. But when the fast moving cricket ball hits a spectator, it may hurt him, right? So in the same way, a truck which is at rest does not require any attention when parked along a roadside. But a moving truck, even at a speed as low as 5 meters per second, may kill a person who is standing in its path. In the same way, a small mass such as a bullet may kill a person when fired from a gun. So this observation which suggests that the impact produced by the objects depends on their mass and velocity. Similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity, right? So the impact of the body depends upon its mass and velocity. So, okay, whether the momentum of particular object remains the same? No, right? So it differs because it changes when when the velocity changes. So it changes as the velocity changes because as we know, if we consider one object which is moving, its velocity may change, but whether its mass changes, no. The mass remains constant, but velocity varies, right? As the velocity changes, what happens? Momentum also changes. So that means what is change in momentum? How the momentum changes? So we know that momentum is equal to mass into velocity. So change in momentum is equal to if the velocity changes. So if there is change in velocity, that is, so how to find the change in velocity? New velocity minus old velocity means final velocity minus initial velocity. If you do, we will get the change in velocity. So change in momentum is equal to mass into change in velocity, that is final velocity minus initial velocity. Change in momentum is equal to m into v minus u. So if with respect to time, if we consider rate of change of momentum, we call it as. So what is rate of change of momentum? It is the change in momentum with respect to time. So change in momentum divided by time, if we do, we are going to get rate of change in momentum. So what is change in momentum? Mass into v minus u divided by t. So change in momentum is m into v minus u. If you divide it by time, we get rate of change of momentum. So we know that v minus u is equal to t. You had learned this first equation of motion. V is equal to u plus at. From that equation, we can substitute v minus u is equal v minus u divided by t as a. So what happens? Rate of change of momentum is equal to mass into acceleration. Hence, rate of change in momentum is mass into acceleration. So that means the force is depending on change in momentum. That means here momentum P is mass into velocity, where force is depending on mass and force is depending on velocity. That means force is depending on change in momentum. So greater the mass, greater is the force, greater the velocity, greater is the force. That means greater the force, greater is the change in momentum. So greater the change in momentum in a given time, greater is the force that needs to be applied. So as the momentum increases, change in momentum increases, the greater force is required. So now acceleration is produced when a force acts on a mass of the force acts on a mass of object being accelerated. So the greater the mass, the greater is the amount of force needed to accelerate the object. Yes, so acceleration is produced when the force acts, right? So the Newton's second law gives us an exact relationship between force, mass and acceleration. So it can be expressed as F is equal to ma. So now what is Newton's second law of motion? What it states? So it states that the rate of change of momentum of an object is directly proportional to the applied force in a direction of force. Yes, so what is the mathematical formulation of the second law of motion? So if an object of mass m is moving along a straight line with a velocity u and which is accelerated with a velocity v in time t by applying a force F, then initial momentum will be P1, which is equal to m into u. Final momentum P2 is equal to m into v, final velocity. So what is change in momentum? P2 minus P1. So mv minus mu. So m into v minus u. Here mass is constant. So rate of change of momentum is m into v minus u divided by t. So with respect to time. So force applied F is directly proportional to rate of change of momentum, that is m into v minus u by t. Therefore F is equal to m into a. F is directly proportional to mass into acceleration, and if the proportionality sign is removed, we get a constant of proportionality. So F is equal to K into M into A, where K, if we take it as 1, so F is equal to MA is the equation of second law of motion. So the SI unit of mass is kg and that of acceleration is meter per second square. So the unit of force is kg meter per second square, or it is Newton, where it is symbol is capital N. So Newton's second law of motion states that the rate of change of momentum is directly proportional to force applied. Okay, so F is equal to ma is the equation for second law of motion. Now let us see the applications of Newton's second law of motion. A cricket player moves his hand backward on catching a fast moving cricket ball. So a fast moving cricket ball has a larger momentum. In stopping this cricket ball, its momentum has to be reduced to 0, right? So when a player moves his hand back, the time taken to stop a ball increases, and hence the rate of change of momentum also decreases. So that is, the force exerted by the ball on the hands decreases, so the player may not get hurt when the ball he catches. In the same way, the second application is that when a player doing a high jump or a long jump, an athlete is provided either by the cushion or a heap of sand on the ground, so that the cushion and sand helps to increase the time in which the momentum comes to 0. This decreases the rate of change of momentum and hence the force, so that athlete does not get hurt. In the same way, the third application, packing materials like thermocol, this bubbled plastic sheets, straw, paper strands, etc., which are used for packing this mobile and glassware, chinaware, electronical devices, all are just packed with this thermocol and all. So what is the reason for that? That is because when there is a jerk, so where force, what happens, there decreases the rate of change of momentum and hence the force. So the articles do not get broken. Due to that reason, thermocols are used. Okay, so these are the applications of Newton's second law of motion. I hope you all have understood Newton's second law of motion statement, and the mathematical derivation is important. Okay, in the next class, let us study Newton's third law of motion. Thank you.